Good morning, guys. Today we're going to start a new lesson called The Shape of Things, Classifying Shapes on the Coordinate Plane. Warm-up, we're going to do a couple of these. So determine the length of each hypotenuse, round your answer nearest tenth. So the way we do this is kind of getting into some of the Math 2 stuff, getting you guys ready for next year. We find out our hypotenuse is, it's a Pythagorean theorem where we do a squared plus b squared equals c squared. So this is our c, this is our b, and our a. So 4 squared plus 10 squared equals c squared. So 4 times 4 is 16. 10 times 10 is 100, which comes out to be 116. So now we have to square root it to find out the answer. So we square root 116. We go to our fancy calculator. It looks like this one. If you hit the second and then where it says x2, which is on the left hand side about middle spot, gives you that sign, and we type in 116, it gives us an answer of 10.77. So we'll just round up to the nearest tenth, which is the first number after the dot. So our answer would be C is equal to 10.8 is our answer. Now this one, same thing, 5 squared plus 5 squared equals c squared. 5 times 5 is 25 plus 25 comes out to be 50. We do the square root of 50. Come back to our calculator, we hit second, the x2 again, type in 50, comes with 7.07, which we round up to 7.1. So C is equal to 7.1. Now this next one, same thing we've been doing, 7 squared plus 30 squared equals C squared. So to make things easy, we can type in here 7, and if we hit that x2, gives us squared, plus 30x2 gives us 949. We hit second, that symbol, and type in 949. Comes out to be 30.805. So we just type this in as C is equal to 30.8. And the last warm-up gives us again 20 squared plus 15 squared equals c squared. We type this into our calculator again. 20, hit the x2, gives us a squared, plus 15 squared gives us 625. We hit second, x squared, gives us the square root sign. We put in 625, and it comes out to be a solid number of 25. So our C would equal 25. That is how we use that formula to answer those questions. Okay. Now, let's see if I want to go over this one. We're not going to do the warm-up. We're just going to go straight into activity 1.1 because they're asking us to cut things, and I'm not going to have you guys trying to print and cut things. So, calculating distance on the coordinate plane. Let's analyze quadrilaterals that lie on a coordinate plane and classify them by their properties. Okay, consider quadrilateral ABCD. So ABCD. So should be able to tell, hopefully, square. Classify the quadrilateral, justify your reasoning. So we can sit here and say this is a square. And what we can say, because if we look at this, we can count. We're going over 1, 2, 3, 4, 5, 6. So this is 6 squares here. And we're going to count 1, 2, 3, 4, 5, 6 squares here. So this is a 6 by 6. So you can say this is square because it has 4 right angles meaning right here in the corner. So this is something that's going to be coming up in Math 2 next year for you guys. As well as 6 units left/right, meaning going left and right, and 6 units up/down. So that's what we counted out there before. So they're congruent sides, okay? Now, determine whether quadrilateral EFGH can be classified as a parallelogram. Justify your reasonings, okay? So number 2 is going to be a little different, okay? If we look at this, we can see that if we go from this point here, H, we're going up, up 1, 2, 3, 4, and we're going to go over 1, 2, 3 spaces. Okay? So we can see that that's got a slope of 3/4, going up 4 over 3. I'm sorry. I should write it the other way around. Rise over run. So 4, 3 there. We're here. We're going to go rise. So this is going to be a negative because we're going down. We're going to go down 1, 2, 3. So -3 over 1, 2, 3, 4. And we look at this one, we're going to go down again. 1, 2, 3, 4. And we're going to go over 1, 2, 3. So this is -3 over 4. Oh, I'm sorry. I'm flipping them around. So this is a 4 over 3 because you're going technically up because this is going up. And then this one would be a down here. So 1, 2, 3. And then over 4 there. Okay, so we can say, just fine by looking at this is a parallelogram because EF, line segment EF, and line segment HG have a slope of -3/4, and HE, line segment HE, and GF have a slope of 4/3. So that will work. Okay? So they have the same slope and they're opposite sides. Now number 3 asks determine whether quadrilateral EFGH can be classified as a rectangle. Justify your reasoning. So if we look at this, we can kind of figure out that this is a rectangle because you can't count like we did the last one, but you can look at this and see how you calculated the slopes in the previous question. So this is technically, yes, a rectangle because calculated previous slopes and opposite sides are congruent. So what that means is that EF and HG are congruent, but FG and HE are congruent to each other, meaning that they're the same. But EF is not the same as HE, and EF is not the same as GF. Now we're on to number 4. We're going to finish this page here and probably call it a day. Or we'll do part of this page and we'll call it a day. So we'll do maybe 4 and 5. Okay? Now consider quadrilateral EFGH shown. What information do you need to classify quadrilateral EFGH as a square? So we need to know in order to tell if this is a square, obviously a square is different than a rectangle. Rectangle, one side's going to be longer than the other, whereas square is they are perfectly the same on each side. Okay, so we need to know, so I'm going to write right up here, need to know if all side lengths are congruent. So it's going to be a word you're going to hear quite often, congruent, or I'm going to write over here what it means. Same length. We're just going to put right here in parentheses. So mean it's the same. Okay, so they're exactly the same. And the last one we'll do for today, on quadrilateral EFGH, draw a right triangle EFR such that line segment EF is the hypotenuse. Use the Pythagorean theorem to determine the length of EF. So essentially what we are doing is they want us to write a right triangle. So we're going like this, up here, over here, and we're going to write this as R. And we can count and see that 1, 2, 3, 4 spaces are here. And there's 1, 2, 3 spaces here. And we need to find out what this is here. So it's the same thing we did in the beginning. 4 squared plus 3 squared equals, I'm going to put this as x squared. So 4 times 4 is 16, plus 3 times 3 is 9. Comes out to be 25. Square root of 25 is equal to 5. So essentially this x is 5 units long. Okay? Now, that is where we're going to stop for today. Or I shouldn't say x, EF. I'm sorry, guys. I'll write this as EF. Because that is what our segment here that we're trying to find is. I'm going to stop there for today. If you have any questions, please feel free to reach out to me, and I can help you with anything you have. Have a great day, and I'll talk to you guys tomorrow.